Good morning, students. So, in the series of lectures in operating system, uh, in this class, I'm going to discuss about threats. What is threats? What are different types of threats? What is the role of threats in operating systems? So, first we see what is threat. A threat is a flow of execution through the process code with its own program counter, system register and stack. So a thread is also called a lightweight process. Threads provides a way to improve application performance through parallelism. So each thread belongs to exactly one process and no thread can exist outside a process. So if we see the single threaded process and multi-threaded process. So single threaded process and multi-threaded process, you see in single threaded process one thread is exists in entire process. So here code, data, files, registers and stack and this thread of control. So ultimately this is the single threaded process. So here in multi-threaded process multiple threads exist and each thread has its own code, register and stack. So this is the multi-threaded process. So if we see how process and threads differ from one another, so it is important to see how thread is different from process. So process is a heavyweight or resource intensive, but thread is lightweighted, taking lesser resource than a process. Number two, process switching needs interaction with operating system, but thread switching does not need interact with operating system. Number three, in multiple processing environments, each process executes the same code but has its own memory and file resources. But in case of threads, all threads can share same set of open files, self process, etc. So number four, if one process is blocked, then no other process can execute until the first process is unblocked. But in case of thread, while one thread is blocked and waiting, second thread in the same task can run. So multiple processes without using thread use more resources. But in case of threads, multiple threaded processes use fewer resources. So number six, in multiple processes, each process operates independently of each other. But in one thread can read, write, or send another thread's data. So this is threads are not independent, they are dependent on each other. So advantage of threads. There are so many advantages we see in the threads. Threads minimize context switching time. So comparing with the process, it minimizes context switching time. So number two, use of threads provide concurrency within a process. So efficient communications. Due to threads, the communication system in the OS or process is made efficient. So economy, it is more economical to create and context switch threads. So utilizations of multiprocessor architecture to a greater scale and efficiency. Now disadvantage of threads, blocking of parent threads will stop all child threads. This is one of the important disadvantages. So if we block the parent threads, then it automatically blocks all child threads and security problems also. So types of threads. So there are two types of basically threads in operating system. We see user level threads and kernel levels threads. So ULT means user level threads, KLT means kernel level threads. So what is user level threads? So user level threads implements in user level libraries, so thread switching does not need to call operating system and to cause interrupt to the kernel. In fact, the kernel knows nothing about the user level threads and manage them as if they were single threaded process. So advantage of user level threads does not require modification to operating system, easy to present and manage. User level threads can run on any operating system. User level threads are fast and efficient. So disadvantage of user level threads: there is a lack of coordinations between threads and operating system kernel. So user level threads require non-blocking system call. So this is the disadvantage. So what is kernel level threads? So in this method, the kernel knows about and manages the threads. No runtime system is needed in this case. Operating system kernel provides system call to create and manage threads. So advantage of kernel level threads: kernel can simultaneously schedule multiple threads from the same process on multiple processes. If one thread in a process is blocked, the kernel can schedule another thread in the same process. So another advantage is kernel routines themselves can multi-threaded. Now disadvantage of kernel level threads: kernel threads are generally slower to create and manage than the user level threads. So kernel requires thread control block TCB for each thread in the pool, hence complexity increases. So difference between user level threads and kernel level threads. So user level threads are faster to create and manage. Kernel level threads are slower to create and manage. Number two, implementation is by threads library at the user level. So in case of kernel level threads, operating system supports creation of kernel level threads. So user level threads is generic and can run on any operating system, but kernel level thread is specific to the operating system. So number four, multi-threaded cannot take advantage of multiprocessing in user level threads. Kernel routines themselves can be multi-threaded. So this is the basic difference. Now multi-threaded model. So some operating system provides a combined user level threads and kernel level threads facility. Solaris is a good example of this combined approach. Solaris operating system. So multi-threading models are three types: one many to one model, one to one model, and many to many model. So see one by one. Many to one model. These implementations of many to one model, that means many user level threads mapped or connect to the one kernel level threads, allows the application to create any number of threads that can execute concurrently. In these implementations, all threads activity is restricted to user space. Additionally, only one thread can access the kernel at a time, so only one schedulable entity is known to operating system. So this is many user level threads are controlled or directly linked with the one kernel level threads. Now one to one. So one to one model, one user level threads to one kernel level threads is among the earliest implementation of true multi-threading. In this implementation, each user level thread created by application is known to the kernel and all threads can access the kernel at the same time. So here one-to-one relationship between user level and kernel level threads. Now many to many and many to many model, many to many user level threads to many kernel level threads avoids many of limitations of one-to-one model while extending multi-threading capabilities even further. The many to many model, also called two-level model, minimize programming effort while reducing the cost and weight of each thread. So here many kernel level threads are connected with many user level threads. Thank you. With this, today I conclude my lecture on threads. I think you will be benefited by seeing this video. Thank you.